Think about that dusty, colorful plastic globe that sat on your teacher's desk back in 3rd grade. That blue marble is the anchor of everything we understand about our reality. Modern astronomy, global navigation, the satellites beaming high-speed internet to your phone, and the GPS telling you to turn left in 500 feet, it's all built on one undisputed fact. The Earth is a sphere, spinning on its axis while orbiting a massive star. But what if we woke up tomorrow morning to find out that the globe was a lie? What if our world wasn't a blue marble, but a massive, stationary disk? How would your morning coffee, your flight across the country, or even the moon in the night sky look if we lived on a pancake instead of a ball? Welcome to Night Question. Before we dive into this rabbit hole, if you enjoy exploring the why behind the world's biggest mysteries, do me a quick favor and hit that subscribe button. It really helps the channel grow, and you won't miss our next deep dive into the unknown. Now, let's get back to the disk. The flat Earth model isn't just a simple statement. It's an entire alternative universe with its own set of rules. Proponents suggest we live on a giant, motionless circle where the North Pole is the dead center of the entire world. And Antarctica? It isn't a frozen continent at the bottom. Instead, it's a 150-foot tall wall of ice that rings the entire edge of the disk, acting like a cosmic bowl to keep the oceans from spilling into the dark void. In this world, the sun and moon are small, localized spotlights, maybe 3,000 miles up, circling above the disk like a motorized mobile over a baby's crib. Above it all is the firmament, a solid dome that seals us in, making the sky a ceiling rather than an endless frontier. To explain why we don't float away, this model often replaces gravity with universal acceleration, suggesting the entire disk is constantly screaming upward through space at 32 feet per second squared. But let's look at the mechanics, because physics is a cruel mistress to a flat surface. First, consider how gravity would actually feel. On a globe, mass pulls toward the center, which is why down always feels like it's toward your feet, whether you're in Miami or Seattle. But on a giant disk, the center of mass is the North Pole. If you were standing in the middle of Alaska, you'd feel perfectly normal. However, the further you traveled toward the edge, say toward the tip of South America, gravity wouldn't pull you down. It would pull you sideways toward the center. Walking toward that massive ice wall would feel like hiking up an increasingly steep, invisible mountain. By the time you reach the edge, you'd be leaning at a 4-5 degree angle just to stand upright relative to the North Pole. And the water? All the world's oceans would be sucked toward the center, creating a massive, bulging hill of water in the middle of the world and leaving the edges as a bone-dry, airless wasteland. Then there's our local spotlight, the sun. In the flat model, the sun circles above us like a desk lamp. But this creates a massive optical problem. If the sun is a spotlight moving over a table, it should just get smaller as it moves away, eventually becoming a tiny dim dot. We should be able to see it from anywhere on Earth with a decent telescope, even at 3 a.m., because it's always up there somewhere. In reality, we see the sun literally dip below the horizon, maintaining its size as it disappears. Plus, a spotlight sun doesn't account for the seasons or why it stays 80 degrees Fahrenheit in the tropics while it's freezing at the poles. On a flat Earth, the sun's light would hit everything at nearly the same angle, making distinct climate zones almost impossible. Let's talk about eclipses. During a lunar eclipse, the Earth passes between the sun and the moon, casting a shadow. It's always a perfect, rounded curve. If the Earth were a disk, that shadow would look like a thin, flat line or a cigar shape, unless the sun was somehow directly beneath the disk, which contradicts the theory entirely. The geometry just doesn't quit. If the sun and moon are both hovering above the disk at the same height, they'd never actually cross paths to create a solar eclipse. It would be like two cars driving in circles on different tracks. They'd never collide. And don't even get me started on the stars. If you're in New York, you see the Big Dipper. If you fly to Australia, you see the Southern Cross. You can't see the Southern Cross from New York, and you can't see the Big Dipper from Sydney. Why? because the physical curve of the Earth is blocking your view of the other side of the sky. On a flat disk, everyone is looking at the same ceiling. You'd see the same stars from every backyard on Earth, but we don't. In the southern hemisphere, the stars even rotate in the opposite direction compared to the north. That's a bowl feature, not a disk feature. One of the most terrifying consequences would be the loss of our magnetic field. Our globe has a spinning, molten iron core that acts like a giant dynamo, creating a magnetic shield that protects us from lethal solar radiation. In a flat disk, you physically cannot have a spinning spherical core. Without that magnetic bubble, the solar wind would strip away our atmosphere in a few million years, turning Earth into a radiation-baked rock like Mars. We wouldn't just lose our compasses, we'd lose our ability to breathe. Think about visibility too. If the world were flat, the only thing stopping you from seeing the Statue of Liberty from the coast of California would be a little bit of haze. With a powerful enough telescope, you could sit on a mountain in the Rockies and watch the ships docking in London. But you can't. Ships sink hull first below the horizon as they sail away. That's not a trick of the eye. It's the physical geometry of a curve. Physics naturally hates large, flat objects. There's a reason every large moon, planet, and star in the universe is a sphere. It's called hydrostatic equilibrium. Gravity is a relentless force. It wants to pull everything into the tightest shape possible, a ball. To keep a disk the size of Earth from collapsing, you'd need the world to be made of some fictional material with a strength we've never seen in nature. It would have to resist quintillions of pounds of pressure pushing in from every side. Ancient thinkers didn't need NASA to figure this out. They used nothing but 2 sticks and the shadows they cast to calculate the Earth's circumference with shocking accuracy. Sailors for thousands of years watched the masts of ships appear before the hulls and noticed that the constellations shifted as they sailed. They didn't need a high-tech lab. They just needed their eyes and a bit of logic. They realized the world looks flat because we are tiny, like an ant crawling on a massive hot air balloon. To the ant, the surface is a never-ending plane. To anyone with a bird's eye view, the curve is undeniable. So, while the idea of a secret ice wall sounds like a great plot for a movie, the reality of the ground beneath your feet is much more dynamic. The globe isn't just a model. It's the only way the physics of our daily lives actually makes sense. Thanks for hanging out with me tonight. If this gave you something to think about, please subscribe and join the Night Question community. It really helps me keep these stories coming. I'll catch you in the next one.